Okay, we're gonna skip one page and go to this next page in our notes that says 120, 80, and 40. And go ahead and write this. I didn't write this. Maybe draw your axes. But with this problem, we're going to calculate the principal stresses, and we're going to calculate theta p, right, the orientation of those principal stresses. Then we're going to calculate the maximum in-plane shear stress and theta s for that one. So first of all, let's just see what we've got here. We've got positive 80, sigma y negative 120, tau of negative 40, right? Remember, the positive would have been pointed up to that corner. Negative 40 is pointed into that corner. Positive is tension, negative is compression. So you got to get those right, or your Mohr circle will be wrong. All right, so draw some axes here. Here's our sigma. Here's our tau. The problem, let's see, I'm going to be drawing some large numbers, 80. So maybe I'll try to break this up into tens, 20, 30, 40, 50, 60, 70, 80, 10, 20, 30, 50, 80. Okay. So the first, what do we do? Go back to our steps, but the more you do this, you'll get it. Right. Step 1, draw our axes. Did that. Step 2, draw my original point. My original point is 80, comma, negative 40. 80, comma, negative 40. So go over here to 80, and negative 40 is up. And so that right there, maybe I'll draw it, label it, is 80, comma, negative 40. So there's my starting point. Next step, draw the center. The center is at the average of the normal stresses. So 80 plus... So maybe I'll write these out. So step 1, 80, comma, negative 40. Step 2, the average would be at 80, negative 120 divided by 2. Right? So negative 20 is the center. Center is at negative 20 right there. Step 3, the radius. Step 3, the radius. The radius would be this length right there. Let me draw this in purple or something. That length right there. What would that length be? Well, I could find that by looking at this triangle. This triangle does have a height of 40, but it does not have a base of 80. It has a base of 100, right? Because I'll go from 80 to negative 20, right? I go from 80 to negative 20. So a base of 100, a height of 40 would make my circle, let's see, 100 squared plus, right, a squared plus b squared equals c squared, 100 squared plus 40 squared. Take the square root. My radius is 127.7. Maybe write that here, 127.7. All right. Okay, once I've got that, then, and these numbers might be a little bit different from my previous notes, then I'm going to draw my 4 points from the center, right? Start at the center, go radius right, radius left, radius up, radius down. So I'm starting at negative 20, and I'm going to go to the right 127. So I'm starting at negative 20, and I'm going to go to the right 127.7. Oh, I'm sorry, guys. This is 107. 107.7. 107.7. I do have 127. Okay. To the left. Yes, that makes sense. Okay. Sorry. Start at the center and go radius to the right, radius to the left, radius up, radius down. Start at negative 20, and I'm going to go 107.7 to the right, which would take me to 87.7. I'm going to start at negative 20 and go 107.7 to the left, which would take me all the way over here to negative 127.7, which might be a little bit even further if I was looking at my 80. Negative 127.7. All right, I'm going to start here at the center, and I'm going to go up 107.7. I'm going to go down 107.7. All right, then let me kind of try to make an arc. I like to draw my Mohr circle. Well, draw it with a compass if you have it. But I like to draw these 4 arcs. And then I could connect them. All right, doesn't look like a great circle, but there's my Mohr circle right here. Okay. All right, so there we go. There's my Mohr circle. Now, so no matter what the question is asking, I'm going to do those 4 or 5 steps first. I'm going to draw my axes, plot my starting point, plot my center, find the radius, and go from the center, radius right, radius up, radius left, radius down. You could go radius everywhere if you want to, right? Just to get you a good circle drawn. Okay, now let me answer the question. Let me answer. What are the principal stresses? I've already found them. Sigma 1, 87.7 MPa. Sigma 2, negative 127.7 MPa. Now, theta P. What is theta P? Well, that angle right there is 2 theta P. That angle right there is 2 theta P. Let me come down and draw this triangle and find that angle 2 theta P right there. All right, well, this height of that triangle is 40. But again, the base, I've kind of already seen this triangle before. The base is not 80. It goes from 80 to negative 20. The base is 100. So I would say tangent of 2 theta P is opposite over adjacent. So 40 over 100. Second tangent, do inverse tangent. And so it's my calculator spits out 21.8. So my theta P is 10.9, but positive or negative? Okay, my calculator's not going to give me the answer positive or negative. Okay, I started right here, and I went clockwise in order to get to the principal plane, in order to get to the principal stresses. See that? I started here, and I went clockwise 21.8, but remember 2 degrees on Mohr Circle is 1 degree in real life. So anyway, this theta P is negative 10.9 degrees. Negative because in order to get to the x-axis, I went clockwise. If you had gone around this way and done 2 theta P that way, that would have been fine, and you divided by 2, you would have gotten positive something, and your answer would have been the same, just would have been 90 degrees away from my answer. Okay, here we go. Theta 1 and theta 2, sorry, sigma 1 and sigma 2 are 87.7 and negative 127.7. Theta P negative 10.9. Now the maximum shear stress. Tau max, I already have that. It is the radius. So you can either think of that one or that one. What's the maximum shear I'm going to get? 107.7 MPa. Theta S, I could find that angle right there, 2 theta S. But I also know that theta S is 45 degrees away from theta P. And also, 2 theta s plus 2 theta p would add up to 90 degrees. This all is making sense, right? No matter how we get it, I would get my theta s positive 34.1. Why positive? Because I had to go counterclockwise in order to get to this vertical angle. Are these two angles 45 degrees away from each other, hopefully? Yes. And one last thing, what's the normal stress when I have this shear stress maximum? Well, this value right here is 107.7. Sorry. It is negative 20, comma, 107.7. It is at negative 20 MPa, which I already knew that the normal stress was at the average. The normal stress when we have the maximum shear stress is sigma average. Also, what is the shear stress right here? 0. And it's also, you can see that from the figure. What is the x-axis value right here? 0. Okay, so drawing the Mohr circle and finding the principal stresses and orientations and maximum shear stress and orientations, this is how we do it. And it's all inside of this circle. Notice I didn't plug in I didn't use any of these equations. Whoops, sorry. I didn't use any of those equations right here, but I actually did. Those were the same values that are kind of embedded in this Mohr circle. So the Mohr circle is really a way that we can do all these calculations without having to memorize and look up and plug in those formulas right there. It's pretty cool. I don't know. I'm not doing a great job explaining this, how neat it is, how cool it is that those equations form a circle, and that by knowing a circle and knowing these angles and these triangles and looking at these values, we are doing the same calculations that we were doing. It's just a lot kind of easier to visualize graphically those calculations. So this was finding the principal stresses and maximum shear stress using Mohr's circle. Next problem, we're going to go backwards, and we're going to find the stresses at a different angle other than the principal angle, the principal orientation.